Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 200, number of islands. We're given an m times n 2D binary grid, and we're told that it represents a map of ones and zeros, and we need to return the number of islands. We're told that an island is surrounded by water and is formed by connecting adjacent lands, horizontally or vertically, and we can assume that all four edges of the grid are all surrounded by water. So let's say we had a grid full of ones. That would still be classed as an island because the adjacent edges are all water. We're going to examples and we're also given some constraints. So what I'm going to do is hop straight into the code, and I think it will make more sense as we go through the code. So we're going to handle an edge case, which is if our grid is empty. In that case, we're just going to return 0. Otherwise, let's get the number of rows and columns. So we're going to set that equal to the length of the grid and the length of the first row in the grid, which is going to give us the number of columns in our grid. And of course, our island count, which we're just going to initialize to be a 0 first of all. And we want to say for each row in range rows and for each column in range columns, if grid R C equals 1, we know we found an island, so we can increment our islands count and return islands. That would be the answer if this was probably an easy problem, but it's not, because what if we get to, so we will come across a piece of land, so a chunk of land. So we know we found an island, but what if the adjacent nodes, what if the adjacent edges are also ones, they're also land? Well, we don't want to keep incrementing our islands counter because we already know that's part of the island that we've just added to our islands count. So we want to ignore all the adjacent lands. So how can we do that? Well, we can run depth first search, and for all the connected pieces of land, we'll just set those pieces of land to visited, so we don't so the next time we get to them, we don't class them as pieces of land that we should add to as individual islands, basically. So let's initialize and create our depth first search function. So it's going to take a row and column as the arguments, and if the row is less than 0 or our column less than 0, so basically if we add to bounds or row is greater than equal to the length of rows, or C is greater than or equal to the length of columns, or we come across water. In that case, we can just return, because it's either out of bounds or it's water, and we don't want to mark water as visited. We only want to mark the adjacent pieces of land. Then we'll set our current piece of land to water, so we know we've already marked it. And then we can do depth first search on all the adjacent chunks of land. So we can say, we'll do it for the top piece of land as well. For the bottom, we'll do for the right, and we'll do for the left. And that should be all our code, actually. So let's submit our code. Let's check it works. And it does. We passed all 49 test cases. So there's another approach we can do, which would be slightly more efficient, and that's using breadth first search. But just to keep it simple, I decided to go for depth first search to solve this problem. It does take a bit of wrapping your head around, but once you get it, it does make a lot more sense. So in terms of time complexity, well, it's going to be the time complexity is going to be O of n, where n is m times n, so O(n) time complexity, and space complexity is also going to be big O of n. Space complexity is going to be big O of n because of the recursive call stack because of our depth first search function. So I hope you guys enjoyed this video, and I'll catch you in the next one.